All right, let's talk about a challenge that every single cloud architect runs into. You've built an amazing proof of concept on Azure Kubernetes service, but now you've got to take it from a cool demo to a rock-solid, production-grade system. We're not just going to list off some best practices here. We're actually going to build the architect's blueprint right from the ground up.
So picture this. Your app is in containers, you just wowed the leadership team with a demo, everyone's high-fiving, it's a great moment. But this is exactly where we need to pump the brakes and ask that really tough question. Yeah, it works, but is it actually ready? I mean, ready for real users, real traffic, and the chaos of the real world.
And that really is the heart of the problem with a POC, isn't it? It's functional, no doubt about it. It makes for a fantastic demo. But if you look under the hood, it's usually pretty fragile, kind of held together by default settings and a few shortcuts. And trying to run a real service on that, that's a huge risk. So today, we're going to close that gap.
So where do we even begin? Well, just like building a house or a skyscraper, you have to start with the foundation. If you get these fundamental blueprint decisions right from the very beginning, you'll avoid some major, catastrophic problems down the road.
Okay, here's trap number one, and we see this all the time. In that mad dash to get the POC up and running, you picked a Kubernetes version, got it working, and then never thought about it again. But here's the thing, the clock is always ticking. An old version doesn't just mean you're missing out on cool new features. It means you're leaving a wide open door for well-known security holes.
The only way to handle this is to make version management a real discipline on your team. So, rule number one, always run a Kubernetes version that's officially supported. Rule two, you need a real, proactive plan for upgrades. Don't wait for things to break. And rule three, and this is a big one, you never, ever upgrade production until you have tested it, and I mean really tested it, in your dev and staging environments first.
All right, let's talk about the next crack in the foundation. In a basic POC, what do? We throw everything onto the same virtual machines. So you've got your application pods fighting for CPU and memory with the critical Kubernetes system pods, the ones that literally keep the whole cluster running. This is a recipe for total chaos and really unpredictable failures.
The answer here is actually really elegant. You separate them using node pools. You create what's called a system pool, and it's a protected, dedicated space just for those critical system pods. Then, all of your applications live in their own separate user pools. It sounds simple, but this one act of isolation is one of the biggest things you can do to make your cluster dramatically more reliable.
Okay, our foundation is solid. Now it's time to build the walls. And this is where we have to talk about security. Not as some feature you bolt on at the end, but as a fundamental part of the design from day one. And this is a question that should honestly keep you up at night. In a default cluster, access control is, well, it's a mess. Who has the keys to the kingdom? How are your apps talking to other Azure services? If you don't have a clear strategy for identity, you're basically flying blind.
We can lock this down with a really strong three-step baseline. First, you integrate with Microsoft Entra ID for all human access. No more sharing admin credential files, please. Second, for your applications, you use managed identities. This lets your pods talk to other Azure resources securely, without you ever having to store a secret or a password. And third, you enforce the principle of least privilege, everywhere. Only grant the absolute minimum permissions needed to get a job done.
Now this is one of the biggest security holes in a default AKS cluster, period. The Kubernetes API server, we're talking the central brain of your entire cluster. It just sits there with a public IP address, visible to anyone and everyone on the internet. It's like putting up a giant flashing neon sign for attackers. So how do we lock this thing down? We use layers of defense. First, make your cluster private. That takes the API server off the public internet entirely. Gone. Second, you control traffic inside the cluster with network policies, basically creating firewall rules between your pods. And third, you filter traffic at the network edge with NSGs. It's these layers working together that create a truly hardened perimeter.
Okay, our foundation is stable, our walls are secure. But let's be realistic for a second. Production systems fail. It is absolutely going to happen. It's not a question of if, it's a question of when. So our next job is to install the alarms so we're ready for it.
And this is just the gospel truth of running any system. When that alert goes off at 2 a.m. and a customer says things are broken, you cannot afford to be guessing. You need data. You need logs. You need to be able to see inside that black box and figure out what's happening right now.
This is where observability becomes absolutely non-negotiable. And it really comes down to three things. You need monitoring to see how things are performing. You need logging to have all your troubleshooting data in one place. And you need alerting to tell you when things are about to go wrong, ideally before your users even have a clue.
Now it's time for the final exam. We've thought about pods failing, nodes failing, but what about the big one? What's your plan when an entire Azure region goes down? If you can't answer that question with confidence, you aren't truly ready for production.
So here's the bottom line. Hope is not a strategy. Crossing your fingers is not a DR plan. A real production service requires a well-defined, documented, and, most importantly, tested plan for both backing up your stuff and recovering your entire service in a different region when things go sideways. For any critical system, this is an absolute must.
We've covered a ton of specific tactics and best practices, but to wrap this all up, I want to leave you with something that's way more powerful than just a checklist. I want to give you a mental model, a framework you can apply to any design decision you ever have to make.
You see, checklists are great, but technology changes so fast they become outdated. What you really want is to think like a senior architect. And that means for every single choice you make, you need to look at it through these 5 critical lenses. And here they are. For every decision, ask yourself, does this make my system more or less reliable? Does this choice increase or decrease my security? Will it meet our performance goals? What's the cost impact of doing this? And finally, does this make the system easier or harder for my team to actually run and operate? This framework, this is your new compass.
So, we have just walked the entire path, from that fragile but exciting POC all the way to a hardened, production-ready system. But the journey doesn't stop here. The real question I want to leave you with is this: how are you going to take these 5 architectural lenses and apply them to your next design?